Welcome back to our Python class, and today we will talk about Legos. No, actually we will talk about functions. So what is a function in Python, and in general, I think you might have some idea already, maybe from school. So technically speaking, it is our basic building block of managing our complexity in our larger programs. And for you to follow along this lecture, we'll look at day 7 materials and fun. Fun.py is where the materials will live. So there's a formal idea comes from mathematics. We've probably seen it in when you make a function in algebra, right? You have some values, you have some parameters, and you have a result, right? You have some inputs and you have some outputs, right? So in a nutshell, Python functions are extremely similar, except we'll see there are some differences. You don't really necessarily need inputs and you don't necessarily need outputs. In fact, that's the simplest functions in Python will not have any inputs, will not have any outputs. So let's get started. So what is a function? Let's ask what is a function? Let's ask our AI helper. Right. So thank you, Copilot. A function is a block of code that is designed to do one specific job. So that is a Platonic ideal. So that is the above. The above is a Platonic ideal of a function. Not always possible, right? Not always true, right? But yeah, so that's in a nutshell is what you want to strive for. That's your goal, right? But of course, sometimes functions have some extra craft or some extra details which may not be relevant. But okay, so let's imagine we have some instructions, right? We want to go eat and we're going to order food, right? Maybe we'll do something else and we want to go out again and let's order some more food. Let's order some more food again, right? Something like this, right? And of course it will run, right? Or code runs. Let's take, right? So we order. But so notice this, right? These two instructions, right? They're extremely same, right? So if we have more code later on, maybe we have some maybe we have some calculations, maybe we have something else, right? And we want to run these two instructions. Wouldn't it be nice if we could combine them, right? So that's actually what our simplest functions will do, right? So how do we do it? We do something like this. We use def, we use the def keyword, definition maybe, define, right? And then we type the function, name of the function. So let me comment this out. So this is the simplest definition. So go eat, define, go eat, empty parenthesis. This means we have no parameters for now, right? And we have a colon. So what does colon mean? Remember, always in Python we have indentation, right? And this is where your block starts here. And we're gonna go calling function go eat. We're gonna eat some fast food. Let's order some food and pay and leave. Okay, that's great. And let's run it. Let's run our code. And what do you think will happen? Will anything happen? Let's take a look. Well, the code runs. In fact, you notice there's an outline. You can go to, if I scroll up and if I go here, I can jump to the go eat function. However, nothing is happening in the program. So what's the case? Why is nothing happening? Well, that's because we defined our function. We gave some instructions what to do, but we didn't actually call it. So you need to call the function to actually make it work, right? So let's do that. We can do it one time. Right? We'll do it one time and now it works. Now you run it, right? I can run it again, right? Let's go do something else, right? Again, maybe I'll pull this up a little bit more, right? So you can see more code, right? And so go eat food, order, pay and leave. Again we call it again. And then we print, do something else, right? Where is it something else, right? Let's do something else, right? And I could do a loop, right? I could do it, put it in a loop and do it 4 more times, right? So, and run it like this, right? So I run it 6 times, 1, 2, and then 6 times here, right? So I ate a lot of food. So, so calling function basically in some languages called procedure in this case because you have no parameters, you have no outputs, right? But in Python you call them everything is a function basically. So, underscore, what's the underscore here? Basically, we used range 4, right? But we didn't really care for in this case, we don't care about the parameter, right? We don't care about the number, right? So this use underscore to represent a variable which we don't care about, right? So that's a very typical Pythonic thing. Okay, and of course we can run it separately, right? Okay, so that's how you call a simple function, right? Okay, let me comment out all the go out eat, and we are still remain, or definition remains still. But okay, let's go order some food. Right, so this function, this simple function, of course, is good for organizing code. If you name it correctly, right? It's good for, again, if you decide your eating habits have changed, right? You can adjust it here, and on when you call it 6 or 7 or 10 or 15 places at one, 15 places, the instructions will be changed immediately, right? When you run it, when you run the code, right? So now. Let's do something slightly more interesting, right? So I'm going to define a function, and very often functions will have parameters. So let's make a function which has a parameter. So it's called order food. Again, very similar function, but in this case we have a parameter. So notice dish. Dish is a parameter. In fact, notice even here when I uncomment in the code, or my outline mentions this, right? You can see dish, right? So this is going to be, well, think of it also kind of like a local variable for this function, right? Actually, it's a parameter, but we'll be using it inside this function, and the dish will be gone when we finish the function. So let's run this. So let's order some potatoes. So let's take a look again at our code. So we have defined the function order food, dish, right? Dish is a string. So this line is because we might be ordering some strange food, which is not a string, right? Again, remember, Python is dynamically typed. We might have some strange data types coming in. In this case, it's a little extra safety. It's not always needed. In this case, it's only reason I added this line because I'm using capitalize. And remember, capitalize is for strings, right? If I don't have a string, capitalize will fail with an error, right? So it's a little extra safety. Maybe, again, if you're sure you're always getting a string dish, right, a textual dish, then you don't need this. Okay, so we have a function, and let's run it. So this is gonna, if I don't have this, right, if I comment this out, nothing will happen. I have two functions, but I am not actually doing anything, right? I have declared them, but I'm not running. So now I'm define the functions as well. So I'm gonna order some food, right, and now I'm ordering potatoes, and potatoes should be pretty tasty. Let's order some more food, right? So let's order some more food. Ice cream should be pretty tasty. That's also nice, right? Okay, and by the way, I can use a variable. So that's one of the best uses of function. You give it you pass in a variable, so as an argument basically. So notice here, right? My soup, right? So let's take a look here. All done. Let's see how it works here. I'll make a comment here. I'll make a breakpoint, right? And I'll make a print. All done with soup. No soup, done with soup. For now, oh, thank you, a Copilot knows what I want to write. Okay, so let's see how it runs. Run with debugging. Debug is currently active file. So this will be very interesting. So my soup, right now I'm here. I have some function variables, go eat, order food, so they actually are variables actually. In Python, functions are first-class citizens, so you can use them actually as variables, right? But okay, but now let's run it one more time. So my soup is called beet soup. So this is locally and globally, right? So locally and globally, right? Until now, there is no real difference in local and global scope, but for now, this is gonna change this very moment. Right, these things will change, and I'm going to go in order food, right? So this is going to be, so notice something, right? So locally, I'm right now in the order food dish, order food function, right? And my local variable here, my parameter here is the dish, right? Well, globally, my soup is still global, right? So two different things. So basically, you can think in this case, well, it was actually a copy, right? In this case, right? We'll see there are also more complex data types. You will not have a copy, but you'll have you'll have a reference to it. But let's see how it works right now. So we have a dish, right? And let's go to this function. So it runs the function. So notice again, locally we are here basically. right? It is, I like to make an analogy with the movie Inception, right? Where you had these multiple levels of dreams, you call one function and you go in. In fact, if you think about it, right? We printed food, right? We are done. This is a function, so my order food function, right? If I go here, right, my order food function, right? It's using, well, it's calling a print function, which is not my function, but it's actually made by Python. So we're actually going 2 levels deep, right? So this might be a time to remind yourself that there are built-in functions, right? So these are the built-in functions, right? So those are, you generally don't want to redefine them. Technically it's possible, right? You don't want to make a new variable out of these, right? The names, like list or length or sum, for example, right? So and most of them are pretty easy. Well, there's some very specific ones. Again, you don't have to learn all of them. Just be aware where to find them, right? And so you don't accidentally, overwrite. So we in effect we are so print is a built-in function, right? So something, yeah. So again, right? So we were using it. We're going 2 levels deep, right? We called our own function order food, which called print function, right? So these levels, this going deeper, like I said, I like the analogy with movie Inception. You have these multiple levels of dreams. If you remember the movie, right? You can go 3 or 4 levels deep in the movie. In functions, in programming, you can go 10 levels deep, actually, right? One function calls another function, and another function, and another function, and they all have their own contexts, meaning they have their own variables, right, and their own scope. Okay, so we ordered some food. Again, we can order. So because I ordered food because my function is actually, well, it's meant for, it takes anything, right? I can order food even with 555. It's not gonna break, right? I'm ordering 555, right? It works because my order food function has this conversion, right? If I didn't have this conversion, it would be a mistake because capitalize does not work on numbers, right? So that's why actually I use this little trick. Okay, but yeah, so what else can we do? So yeah, just remember again, you can't order, the dish is not available, right? It's only available inside the order food function. Very crucial point here, right? So the scope, again, the idea of scope. So functions have scope. Until now, we've been using global scope, and you might be saying, okay, this is a little extra stuff to learn, but why should we have extra scopes? Well, because if you have a complex project, complex program, you'll have lots of variables, right? And you don't want to keeping 100 or couple thousand local global variables is not a good idea, right? Your naming, your managing complexity will become, well, extremely complex, right? So you won't be able to, it'll be harder for yourself, right? So managing scope, right? Keeping variables in the proper scope is extremely important. But okay, yeah, so in this case, Python, we used, well, it was a dish, right? There's no real restrictions what a dish could be. We can also use it to give a list, right? Yes, we can give a function, we can give a list in this case, right? So again, there's no requirement, this is actually a list, right? But so we have defined function eat food list, right? And this will actually go, notice it will go 1 level deeper. So for each item in our food list, it will use the order food item function. Quite useful. So we have 3 levels deep, or dreams, right? Get 3 levels deep. We have a global dream, and then we have the eat dream, and then we have order food dream. Again, pardon my analogies, right? But again, really, if you have not seen the movie Inception, you should. Again, so if you can understand the dreams in that movie, you can understand programming, no problem. So, okay, once again, I'm gonna quit ordering food for now, right? And we'll see that nothing happens, right? Yeah, nothing happens. I have 3 functions. I can go here, the order food, eat, right? But I have not called it. So let's do that. So let's make a food list of items I want to eat, right? And I'm gonna pass it to the eat function, right? And then of course I can print all done. That's basically right. So eat, right? And again, I'll make a again, I'll make a breakpoint. Do you have another? I'll get rid of this breakpoint, right? So food list, let's run it one more time with the breakpoint. I recommend you, if this is hard to follow, do it yourself. Start debugging yourself and see what happens. So again, we are, right now at the moment, we are, our globals and locals are exactly the same, right? Go eat, order food, we have function variables. We have nothing else, right? Eat, again, function variables. Let's go one level deeper. So I have food list, again, I have not started eating, yeah, right? So I'm gonna go now one level deeper into eat function. See, and now I'm in eat function, right? And notice my local variable, right, is food list. Well, actually, you might say, okay, it looks the same name, right? Actually, well, this is actually a reference to this list. It's actually not the same, exactly the same, right? But we'll order some food, right? We're still in here, and now for food item and food list, right? We are going to go in, right? So locally, I have food item, right? I'm still in the eat function, right? And I am going to now go in a third level, right, into order food function, right? And I'm passing in the food item, right? And again, so inside this food item is now a dish, right? And I'm using it as dish, right? I'm ordering dish, right? And capitalize, of course, right? And soup should be pretty tasty. And again, I have not quit all my dreams. I'm still one level deeper, right? So I'm still in the eat function. I'm going to the next food item. So my food item is going to be now potatoes. I'm going to go inside the order food function, right? And now I have ordered all the potatoes. And let's order for more. Last thing, we have ice cream, right? We have ice cream. And food item becomes ice cream. And I'm going to pass it in, right? Okay, so... And then, of course, now I have no more items to pass in, right? Nothing, I think, right now. Let's see. And let's eat, right? We're going to eat. We still need function. And then let's leave and be happy. We still need eat function. And now I'm basically going to be all done. I'm now in global scope, right? And I'm going to print all done. And everything is done. Okay, so again, I can use, again, the usefulness of these functions is that I can pass in another list, right? Again, the only thing what you have to take care is you pass in the correct number, correct data types. That's advantage and disadvantage in Python because well, it's not checking your data types. It's not strictly typed. There are languages which are strict. Python is extremely loose, right? It says, okay, you want to give in garbage, it'll take garbage and maybe it'll throw an error. So right, so I can call and eat. Let's see what the onions. I'm eating onions, cabbage, and beans. Okay, maybe not so great. So the funny thing is, I can now even eat a potato, right? Again, back to our friend. So what's going to happen here is, if I eat a single, so this is what's going to happen here. This is going to be just a single potato, right? Because I'm giving a list, right? It will be, I'm going to eat a potato. However, what happens if I pass in this? What's going to happen? I'm passing in a string, right? So if you go into this function for food item, food list, this food is not going to be a food list, it's going to be a string, and this will be each letter, right? Again, a little maybe slightly unexpected, but it's possible, right? Again, so I do each, I'm ordering L, I, S, and I'm eating each letter by letter. Again, because of course I did not pass a list, I passed a string. So yeah, this function will take anything you can iterate, and there's not going to be an error. Okay. So far so good, right? We can give in regular numbers, we can give in lists, and let's stop the eating, right? Stop the eating. I can leave the food list maybe out, but I will move on to next function, right? So next crucial thing is, well, we can have more than 2 parameters. We can have 2 parameters, right? So something like this, right? So again, remember, we do not have any. Again, we have now 4 functions, right? And this has 2 parameters. Again, I call them A and B. In this case, because it's sort of algebraic function, it's fine. Again, maybe you can come up with better name, first or second, maybe if you want. And so how do we run it? Again, I have 2 prints here, right? So function definition ends here. And let's run it. So I can run it simply like this, right? Add 3.332 should have 325, right? Yeah, adding 3 plus 3 2. So, right? And result is here. Okay, that is great, right? So let's do some more additions, right? Of course, again, of course, it's silly because we already have addition in Python, so we can use it. But there's a slight problem with this function. It only does side effects, right? So that's slightly not so great. So because you'll see, notice if I run this, right, this will be nothing, right? So let's take a look. So I added 10 and 25. It worked. The function worked. So what happened here? So this function did its work, right? It added 10 and 25, as you can see here, and printed also 10 plus 25 is 35. But the thing is, how do I save this result? If all I want to print, sure, I could use this type of function. But if I want to save the results for future, right, for other function, for more maybe saving in the database, saving in a text file or somewhere, right, again, for doing some processing, right, you probably want to return something. So by default, these functions return nothing. So without return, Python functions return special none type, right? It's special type, none type, right? Which is fine. Sometimes you don't need anything, right? But if you're doing some sort of like mathematical function or something which, doing some processing, right? Well, you will get nothing. So it's similarly, by the way, print is the same thing. Yeah, print itself also. My print result, print 2 plus 2, right? What will happen? It prints 4, right? It printed 4, but again, same thing. I'm getting none because print, if you hover, returns none. You see, our documentation is saying, yeah, print is a good function, but it returns none. So let's define another function, right? So if you want to get something, right, let's define a function which returns something. Let's do a multiplication function, right? Well, so this function actually does 2 things, right? Well, it creates a result. So this result, by the way, this result, right, it only lives inside this function, right? It does not live outside, right? But I'm going to return result for use by, well, the outside, whatever you want to use. You can save it in a variable, you can print it, right? But it also has a side effect. So side effect is, classical side effect is print, right? We are printing something to the console, to our screen, right? So this is not always needed, of course, because printing is a heavy operation, right? But let's see what happens now. So let's run it. Let's first see if anything happens. Nothing happens. So I can do this, right? Mult, some numbers. So 2 and 6, right? So it still works. I mean, I still get 2 plus 3 times 6, but I didn't save it. So nothing. But I did not save the result. So let's save it. My result equals, yeah. Now I have saved the result and can use it later on, right? So let's do something like 20, right? So you can see it, right? Print my result, right? So this is very important, right? Because, right, the basic kind of functions, if you can return something useful, of course, it will be quite useful, right? So my result is now 60, right? And it has a global scope. So this regular result, again, the name could be anything, is gone, right? In this moment when I'm printing my result, it's not this value is gone, A and B is also gone, right? It only lives inside when we call this multiplication, right? It only lives through there. So yeah, I had students ask me about more parameters. Of course, if you want 3 parameters, sure. Echo, right? We can print 3 together, right? So yeah, we can print C, right? Let's do D again. I'll do D. Maybe it's a little bit more clear, but doesn't matter, right? A, B, C, D, right? Not very interesting, maybe, right? Names are not great. You probably should strive to better names, right? Try to name them better. But of course, here A plus B, C, D, right? Is is sort of, again, for a short function, it's okay. If it's longer, you should probably figure out some better names. Right, so, I didn't call it, by the way. Yeah, I didn't call it, but of course I could do something. All right, let's do this one more time. So echo 5, 6, 7, right? So we'll have, what is that, 18, right? But again, it prints all of them. But how would I get out this echo without saving? What I can do is print echo, right? So what's happening is we are chaining functions, so echo is going to be called, and it will print out this print, these 5, 6, 7, 18, right? But also it will return 18, and if we're returning 18 here, it will be available for printing, right? We're not saving it in a variable in this case. We could have saved it, but it will be available for printing. Yeah, an 18. Okay, so let's go to our final big combination, right? We can do strange things like this. So we can actually, let me put here, right? Let's run a debug session. It might be most useful. So we have global food list. We still have food list. We have my result, right? We have some function variables. So let's go inside. So we have what? We have echo, multiplication, multiplication, multiplication. So what's going to happen? We are going to go inside each of these function calls. We'll get some values. Then we'll call echo function, right? And all the results will be returned to this my result variable, and we'll use print to print the result. Okay, so we'll go again 3-level dreams, right? So let's go inside. Let's take a look. So we are in multiplication, right? We have local global variables 2 and 3, right? We're going to print the result, right? 6, and we're going to return the result, and we are back to this line here. So this one is 6, right? You see, return multiplication 6. So 6 is saved here. We're going to go here. It's going to be 35, right? Yep, 35. Results 35. We're returning it. Yeah, right, so 35. Again, you might be asking, okay, where 6 is, so you can, there's 6 also is saved for this moment, right? We're sort of in between results, right? We have 6, 35 here, and we'll have 8 here, as you can expect, right? We'll have 8, 2 plus 8 times 8, and we get a result, should be 8. So now we are ready, 6, 35, and 8, and those will be passed to the echo function, right? Yep, we are inside echo function 6, 35, and 8, and of course we'll add them together, right? D is now 49 again in this local scope, in this scope within this function, right? This context, again, scope, you think of it as a context, right? And then it's all going to be gone, except we're going to return D to save into, I think, what's it called? My result. So my result is going to be not 60 anymore. It's going to be return 49. It's going to become 49. Yeah, it is 49, right? Again, we are all now fully global, so local and global scope is exactly the same, right? And I'm going to print my global, my result. Okay, so that gives you 49. Okay, I hope that serves as a good starting point. We'll in the lectures, in our live lectures, we'll talk about default parameters. We'll talk about modifying values inside our functions, right? But returning multiple values. But for now, this is, I think, quite useful, and maybe you can use this for your assignment, for your prime. Maybe you want to make a function that checks if a number is prime. How does it know that? How does Copilot know that I want to say prime? Because the prime is nowhere to be found in this file. Is it really listening to my mic? I don't think so, right? It's probably using my GitHub repository for prime, mentions of prime before, I would imagine, right? So yeah, and then you can subdivide your work in smaller chunks. That's one of those. So using functions to subdivide your code in small pieces is, well, what does it say? Well, yeah, something like this. Maybe you want to make a function. Just suggestion. I'm not saying you have to, but maybe you want to try it, right? So that might help you, right? So maybe, for example, we can make a function. We have a few more minutes. Let me add a function, right? Stop recording. We have a few more minutes. So define is odd, right? A very silly function, number, right? So also there's a little trick here. Notice something. In this function, it's of course silly. I'm not doing if. Notice I am not using if. Yeah. So that's another trick, right? By the way, I'm actually one of the following exercises will have this. So notice I'm not using it. because this is a Boolean, right? I don't have to do. Of course, I could write some code here. Of course, right? So it's typical starter, starting out, not mistake, but extra work would be to do an if here. There's no need for if, because if you are returning Boolean, right? If you're returning Boolean, you can do a straight comparison immediately, right? So let's check. So print is odd. Let's say 77, right? Will be true, right? And maybe 78 will be false, right? See, true and false. So quite nice, right? So this may be useful. This idea might be useful for your prime function. Again, if you make a Boolean function which returns a Boolean, you should probably name it is, right? So something to keep in mind. Okay, so we'll follow up in class with some more functions, with some more default parameters, some cool things we can do with functions. And again, if you didn't have functions, your code would be really hard to maintain. So that's one of the primary reasons, is to use good, well-named functions to organize your code, to do small chunks of tasks at once, right? Don't do too much, right? Function should not be too long. Maybe if you have a 100-line function, that's probably already too long. 20 lines is fine, right? Usually rule of thumb is one screen. So one screen is probably the limit for a reasonable function. There might be, of course, there's always exceptions, but that's just a good rule of thumb, right? All right, so thank you, and we will continue live in the class.